Yes, it is allowable to install a 240 volts single-phase breaker and a 480 volts three-phase breaker in the same panel. The National Electrical Code, specifically Article 408.3a, permits different voltages within the same panel. Additionally, the UL 508 standard for industrial control panels, section 10.94, addresses the scenario, stating that panels with multiple voltages must incorporate barriers or other means to prevent contact between conductors operating at different voltage levels. Several important considerations must be addressed to ensure safety and compliance. Firstly, the panel itself must be rated for the highest voltage present, which in this case is 480 volts. Secondly, the circuit breakers must be appropriately sized and provide adequate protection for the specific motors and their associated circuits. Thirdly, as mentioned in UL 508a, physical barriers or other effective means of insulation must be implemented to prevent accidental contact between conductors carrying different voltages. Finally, the panel must be clearly and conspicuously labeled to indicate the presence of multiple voltage systems. This labeling should be easily understandable and readily visible to anyone accessing or working on the panel. To delve deeper into these requirements, the National Electrical Code Handbook and the UL 508 standard are invaluable resources. These documents provide detailed explanations, examples, and interpretations of the relevant code sections and standards. When dealing with electrical installations involving multiple voltage systems, strict adherence to the NEC and UL 508 is crucial to ensure the safety of personnel and equipment. Proper planning, component selection, and installation practices are essential to mitigate potential hazards. Regarding the panel, you must ensure that the enclosure is rated for at least 480 volts, which is the higher of the two voltages. This means it is built to withstand the stresses of the higher voltage with appropriate insulation and spacing between components. Consider the short circuit current rating, or SCCR, of the panel. The panel needs to be able to safely handle the available fault current at its terminals. This rating should be clearly marked in the panel. Now let's focus on the circuit breakers. Each breaker must be sized correctly for the motor it protects. This involves calculating the full load current or FLC of each motor using the appropriate NEC tables, such as Table 430.250 for single-phase motors and Table 430.251b for three-phase motors. After determining the FLC, you can select the appropriate breaker size. The NEC provides guidelines for this in Article 430 covering motor circuits. Typically, the breaker is sized at 125% of the motor's FLC, but this can vary depending on the motor type and application. Additionally, you must select the correct type of breaker for motor protection, such as an inverse time circuit breaker, which allows for short duration overloads like those experienced during motor starting. Remember to verify the interrupting rating of the breakers. This is the maximum short circuit current that the breaker can safely interrupt. The interrupting rating must be equal to or greater than the available fault current at the breaker's location. Now about the physical barriers. These are crucial for preventing accidental contact between conductors of different voltages. Barriers can be made of insulating materials like plastic or fiberglass. They should be securely mounted within the panel to effectively isolate the different voltage sections. Consider using separate wiring troughs or channels for the 240 volts and 480 volts conductors to further enhance separation. Another important aspect is proper labeling. The panel should have clear, permanent labels indicating the voltage of each section. Each breaker should also be labeled to identify the equipment it serves and the voltage of that equipment. Use contrasting colors for the labels to make them easily visible. For example, you could use yellow labels with black lettering for the 480 volt circuits and white labels with black lettering for the 240 volt circuits. Ensure the labels are durable and resistant to fading or damage from environmental factors. Grounding is another critical safety aspect. The panel must be properly grounded in accordance with NEC Article 250. This provides a low impedance path for fault current to return to the source, helping to trip the circuit breakers quickly in the event of a ground fault. Use appropriately sized grounding conductors and ensure all metal parts of the panel are bonded together. Consider using a separate equipment grounding conductor or EGC for each motor circuit running back to the panel. This provides a dedicated grounding path for each motor, improving safety. For wiring, use conductors that are rated for the voltage and temperature conditions within the panel. The NEC specifies the allowable ampacity of conductors in Table 310.16, based on the conductor size, insulation type, and ambient temperature. Ensure the conductors are properly sized for the motor's FLC plus any applicable dirting factors. Use appropriately rated connectors and terminals for the conductors. Avoid using undersized or damaged connectors, as these can create hotspots and increase the risk of fire. Torque the connectors to the manufacturer's specifications to ensure a reliable connection. When routing the conductors within the panel, keep them neatly organized and supported. Use cable ties or other means to secure the conductors and prevent them from chafing or rubbing against sharp edges. Maintain adequate spacing between conductors to allow for proper ventilation and prevent overheating. Remember to comply with all applicable local codes and regulations. Your local electrical inspector may have additional requirements or interpretations of the NEC. It is always best to consult with the local authorities before starting any electrical work. Consider conducting a thorough inspection and testing of the panel after installation. This can help identify any potential problems or deficiencies before the panel is energized. Use calibrated test equipment to verify the voltage, current, and grounding connections. Perform insulation resistance testing to ensure there are no insulation faults. After the panel is energized, monitor its performance regularly. Check for any signs of overheating, vibration, or unusual noise. Conduct periodic maintenance to ensure the panel remains in good working condition. This may include tightening connections, cleaning components, and replacing worn parts. Keep accurate records of all maintenance and repairs. This can help track the panel's performance over time and identify any recurring problems. Consider using a surge protective device, or SPD, to protect the panel from voltage surges. SPD can help protect sensitive electronic equipment from damage caused by lightning strikes or other electrical disturbances. Select an SPD with an appropriate voltage rating and surge current capacity. Regarding UL 508A, this standard covers the design, construction, and testing of industrial control panels. It provides requirements for components, wiring, grounding, and safety features. Complying with UL 508 can help ensure that the panel is safe and reliable. Consider having the panel listed by a qualified testing laboratory, such as UL. This demonstrates that the panel has been tested and certified to meet the requirements of UL 508A. The UL listing mark provides assurance to customers and inspectors that the panel is safe and compliant. When selecting components for the panel, choose reputable manufacturers and suppliers. Use high-quality components that are designed for industrial applications. Avoid using counterfeit or substandard components, as these can pose a safety hazard. Before working on the panel, always de-energize the circuits. Use a qualified electrician to perform any electrical work. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and arc flash protection. Follow lockout tagout procedures to prevent accidental energization of the circuits. Be aware of the potential hazards associated with electrical work, such as electric shock, arc flash, and electrocution. Take all necessary precautions to protect yourself and others from these hazards. Consider providing training to employees who work on or near electrical equipment. This training should cover the potential hazards, safe work practices, and emergency procedures. A well-trained workforce is essential for maintaining a safe working environment. In summary, installing both 240V single-phase and 480V three-phase breakers in the same panel is permitted under the NEC and UL 508A, provided that certain conditions are met. These conditions include ensuring the panel is rated for the higher voltage, using appropriately sized breakers, implementing physical barriers between different voltage sections, and providing clear labeling. By adhering to these requirements and following safe work practices, you can create a safe and reliable electrical installation. Remember to consult the NEC and UL 500 data for detailed guidance and to consult with qualified professionals when necessary. Remember that electrical codes and standards are subject to change. It is important to stay up to date with the latest revisions to ensure compliance. Consider subscribing to industry publications or attending training seminars to stay informed. This information is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before undertaking any electrical work.